October 13, 2021. West Texas desert. A 90-year-old Captain Kirk steps out of a rocket. Champagne is spraying. Jeff Bezos is whooping. Cameras are everywhere. And William Shatner walks away from all of it. He finds a rock at the edge of the launch pad. He sits down. He covers his face. And on camera, in front of 1 billion future viewers, he begins to cry. He does not know why yet. Later, he will write this in his memoir, see, quote, "I was crying. I did not know what I was crying about. I had to go off someplace and sit down and think, what is the matter with me? And I realized I was in grief." End quote. Grief. After 10 minutes in space, at 90 years old, what he felt has a name. A space philosopher invented it in 1987, 34 years before Shatner flew. NASA has been quietly measuring it for half a century, and in 2024, neuroscientists finally pinned it inside a brain scan. Last episode I asked if you might be a hallucination floating in cosmic noise. Today is the opposite story. Humans who saw something so undeniably real that language broke. They had to borrow Sanskrit. They had to quote Genesis. They came home unable to describe what they had just witnessed with their own eyes. By the end of this video, you are going to understand what hit Shatner on that rock. You are going to meet the photograph that started it all, and you are going to see how science is finally catching up with what astronauts have been trying to tell us for 60 years. This is the overview effect. To understand the overview effect, we have to go back to the day humans first saw it. December 24, 1968. 1968 had been the worst year in living memory for America. Martin Luther King, assassinated in April. Robert Kennedy, assassinated in June. The Tet Offensive in Vietnam. Riots in 125 American cities. Soviet tanks rolling into Prague. By Christmas, the country was raw. Apollo 8 was a Hail Mary. NASA had lost 3 astronauts to a launch pad fire the year before. The lunar lander was not ready, so they decided to skip the lander and send 3 men all the way to the moon and back, just to prove the trajectory was possible. Frank Borman, commander, test pilot, disciplined, religious. Jim Lovell, navigator, and Bill Anders, 35 years old, physicist, Air Force fighter pilot, the youngest of the 3. His job on the mission was simple: photograph the moon, scout for future landing sites. He had black and white film loaded. On the 4th orbit, the spacecraft rolled. Something blue and white drifted into the window. The transcript of what happens next is one of the strangest documents in NASA's archive, because you can hear in real time 3 test pilots forgetting they are test pilots. Anders, quote, "Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty?" Borman, joking, quote, "Hey, do not take that. It is not scheduled, but Anders is already moving." He shouts to Lovell, quote, "Hand me that roll of color, quick." He swaps the film, triggers the Hasselblad. The shutter clacks once inside a pressurized capsule the size of a small car. Then again, 3 exposures, then back to the moonshots. He puts the camera down. He does not know yet what he has just done. The film travels home in his locker. It is developed in Houston weeks later. And what comes out of the chemical bath is a photograph called Earthrise, a small, blue, white, swirled marble, suspended in absolute black, hanging above the dead gray of the moon. Life magazine will later call it one of the most influential photographs of the 20th century. It will hang in the office of every American president. It will be credited with kickstarting the modern environmental movement. The first Earth Day, less than 2 years later. The first photographs of Earth on book covers, magazine ads, protest signs. That night, Christmas Eve, 1 billion people, 1 in 4 humans alive on the planet, tune in to a live broadcast from lunar orbit. The 3 astronauts read from the book of Genesis. Borman closes the broadcast with a phrase that will echo, quote, "Good night, good luck, a Merry Christmas, and God bless all of you on the good earth. The good earth. Later, Anders will say something even stranger. Quote, "We came all this way to explore the moon, and the most important thing is that we discovered the earth. But here's what nobody noticed at the time. Anders came back, Borman came back, Lovell came back, and something inside them was a little different." Borman, 60 years old, will say in 2016, looking at a print of Earthrise, quote, "It looked so fragile. You have a hard time understanding. There could be so much conflict when it looked so fragile. Anders, raised Catholic, lost his Catholic faith on Apollo 8. He said the smallness of Earth made parochial religion feel parochial. 3 men flew to the moon. They came home thinking about Earth. Nobody had a name for that yet. 3 years later, Apollo 14, the 6th moon landing, February 1971. Edgar Mitchell, 40 years old, PhD in aeronautics from MIT, Navy captain, the 6th human being ever to walk on the moon. The mission, scientifically, was a success. Rocks collected, experiments deployed. The way home was 3 days of nothing. The Apollo Command module rotated slowly on the journey back. It is called a barbecue roll. Engineers use it to keep the heat shield from cooking in the sun. For the astronauts, it means Earth, Moon, and Sun spin slowly past the small window, one after the other, every 2 minutes, for 3 days. Mitchell floated in front of that window. He could not stop looking, and something happened to him that he could not name. He felt every molecule of his body, every atom of the spacecraft, every grain of dust on the moon behind him, every cell of the Earth ahead, suddenly connected, not as a metaphor, as a fact, a direct body-level perception of unity. He came back to the capsule a different man than the one who had left it 3 days earlier. When he got home, he tried to describe it. He failed. English did not have a word. Then a scientist at Rice University in Houston, who had studied Indian philosophy, told him there was already an ancient Sanskrit word for this state. The word was Savikalpa Samadhi, a heightened unitive state of consciousness described in the Vedic tradition 2,000 years before NASA existed. Mitchell spent the rest of his life inside that word. His own description, quote, "It was an ecstasy of unity. I recognized that everything, every molecule, every atom was connected to everything else." Think about that for a second. A Navy captain with an MIT doctorate, a test pilot, the kind of man you send to the moon, precisely because he does not get emotional, comes home, and the first language that fits what happened to him is 2,500 years old. In 1972, 1 year after coming home, Mitchell resigned from NASA. In 1973, he founded the Institute of Noetic Sciences. He set it up specifically to study consciousness as a scientific phenomenon. Mainstream science treated him as the eccentric astronaut, the one who went a little weird. He did not mind. He had been somewhere they had not been. But here is what nobody talked about. He was not the only one. Rusty Schweickart, Apollo 9, March 1969. Spacewalk. His partner's movie camera jammed. Schweickart had 5 unscheduled minutes outside the spacecraft, tethered, with nothing to do but look. He has called those the most profound minutes of his life. Quote, "You look down and you see the surface of that globe that you have lived on all this time. And you know all those people down there. And they are like you. They are you. Borman, fragile. Mitchell, unity. Schweickart, identification. 3 different men. 3 different years. 3 different missions. The same impossible feeling. Nobody had a name for what was happening yet. But somewhere on Earth, a philosophy professor was about to give it one. Mid-1980s, a commercial flight, somewhere over the United States. A man named Frank White is staring out the window. White is not an astronaut. He is a Harvard graduate, a philosophy and policy researcher, a writer. He is on his way to a meeting. He is bored. He is looking at clouds. And then he has a thought that will change his life. He thinks, if I lived up here permanently, if I lived above this layer of clouds, I would think about the Earth differently. It is a small thought, a throwaway. But White cannot let it go. He goes home and starts making phone calls. Over the next 2 years, he interviews more than 30 astronauts and cosmonauts, Americans, Russians, people who had flown in the 60s, the 70s, the 80s. He asks them all the same questions. What did you feel up there? How did you describe it? Can you describe it? And every single one of them tells him a version of the same story. Borman's fragility, Schweikart's identification, Mitchell's unity, Soviet cosmonauts reporting tears they could not explain, astronauts who had seen their own continent vanish behind a cloud and felt something break loose in their chest. White realizes he is looking at one phenomenon with 30 witnesses. In 1987, he publishes a book, Houghton Mifflin Company, 318 pages. The title is The Overview Effect. Subtitle, Space Exploration and Human Evolution. He defines it like this: a cognitive shift in awareness reported by some astronauts and cosmonauts when viewing Earth from orbit or from the lunar surface. A cognitive shift, not a feeling, a shift. The same word a neuroscientist would use. That phrase, overview effect, escapes the book. It enters scientific journals. It enters journalism. It enters pop culture. By the 1990s, every astronaut who comes home gets asked about it. The phenomenon finally has a name. But there is one more thing missing. The world needs to see what those astronauts had seen. Not from 100 miles up, not from 240,000 miles. It needs to see Earth from somewhere truly far, and a man named Carl Sagan was about to fight NASA for 5 years to give us that view. February 14, 1990. Valentine's Day. Voyager 1 is 3.7 billion miles from home, 6 billion kilometers. It has been flying for 13 years. Its primary mission is over. It is now leaving the solar system forever. On the ground at JPL, a man named Carl Sagan has been fighting for 5 years to take one specific picture. He wants Voyager to turn its camera around. He wants to point it back at the inner solar system. He wants to photograph Earth. NASA engineers have been telling him no for 5 years. The sun is in that direction. Pointing the optics anywhere near the sun could damage the camera permanently. The photograph would serve no scientific purpose. It would risk the mission for a single sentimental image. Sagan does not stop asking. Finally, in 1990, with the primary mission complete, they agree. Voyager swings around. It takes 60 individual frames. A mosaic. A family portrait of the solar system from outside. In one of those frames, almost lost, inside a stray sunbeam, refracting through the lens, sits a single dot. Off-white, about 0.12 of a pixel. Barely there. That dot is Earth. Everything that ever lived, every human you have ever loved, every empire, every war, every kindness, every cruelty, all of it, inside that 1/11200ths of a pixel of light. Carl Sagan wrote the prose poem that gave the photograph its name. Quote, "Look again at that dot. That is here. That is home. That is us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." End quote. Sagan was not an astronaut. He never went to space, but he gave the rest of us a way to feel what the astronauts had felt. He shrank Earth down to a single pixel so we could finally hold it in our minds. The picture is the most distant photograph of Earth ever taken, and yet, somehow, the closest the rest of us would ever get to the overview effect. Here is the strange part. Sagan died in 1996. White had named the effect. Mitchell had founded an institute around it. Astronauts kept reporting it, and mainstream science still treated it as something between mysticism and PR. The data was right there. 40 years of witnesses, all saying the same thing, and nobody had measured it. That was about to change. 2016. University of Pennsylvania. Department of Psychology. A young researcher named David Yadin has spent 2 years reading every astronaut memoir he can find, 2 years coding interview transcripts, 2 years looking for patterns. He is trying to do something nobody has done before. He is trying to make the overview effect a measurable scientific construct. His method is unglamorous. He takes the 16 astronaut interviews White published in 1987. He takes another 30 memoirs and oral histories. He runs a thematic analysis. He counts which words repeat: awe, unity, fragility, smallness, connection, bereavement. He maps them. What emerges is not a vague spiritual high. It is a specific cognitive event with 5 reliable components. Quote, a cognitive shift, an emotional shift, a sense of perceived unity, a sense of perceived size, and an enduring change of behavior. End quote. In 2016, Yadin publishes the paper Psychology of Consciousness, the first peer-reviewed scientific framing of what astronauts had been describing for 45 years. 1 year later, in 2017, he publishes a bigger paper with the psychologist Jonathan Haidt, The Varieties of Self-Transcendent Experience. They place the overview effect on the same psychological map as deep meditation, as certain psychedelic experiences, as the mystical experiences described by Buddhist monks and Christian mystics for thousands of years. The same family, different doorways. One of those doorways, just one, happens to require leaving the planet. Now, think about what that means. There is a class of human experience that science has only recently named. We can map it, we can rank it, we can study it, and the proof, the trigger, the reliable way to induce one specific variant of it is to physically remove a human being from the surface of the Earth. Mitchell had spent 45 years saying this. The scientific establishment finally said, "Fine, you were right." But here is the part that still kept Yadin up at night. He had proved it was real on paper. He had not proved it was real in a brain. And then, in 2024, somebody walked into a lab with a VR headset and an EEG cap, and the overview effect showed up in the data. 2024, Tilburg University in the Netherlands, for a group of researchers led by Nina van Limpt. Brouwers builds something strange. It is a VR experience designed to simulate the journey to orbit. The trip up the gravity well, the first sight of Earth from above, the slow rotation. They strap subjects into the simulator. They wire them with EEG sensors. They measure skin conductance, heart rate variability, electrodermal response. The subjects are not astronauts. They are ordinary people, students, office workers, and the effect shows up. Skin conductance spikes the moment Earth appears as a whole sphere in the headset. Heart rate variability changes. EEG patterns shift in directions consistent with awe. The paper is titled Neurophysiological Evidence for the Overview Effect. Journal of Virtual Reality. Springer, 2024. Astronauts had been telling us for 56 years that this was a body-level event, not a mood. The machines finally agreed. 1 year later, 2025, a protocol paper called Sobrain goes further. It combines VR with EEG and transcranial magnetic stimulation. The idea is to not just observe the awe state, to causally interrogate it, to find which networks in the brain produce it. The early picture looks something like this. When awe hits, the default mode network, the system in your brain that handles your sense of self, your ego, your endless internal monologue, quiets down. The salience network, which decides what matters in the world around you, lights up. Prefrontal regions that handle moral reasoning shift. The boundary between self and world thins. That is not metaphor. That is the literal neural signature of what Mitchell felt staring out the window of Apollo 14. Saying it differently, the overview effect is the brain temporarily forgetting that it is a self, and remembering that it is a piece of a planet. And here is the practical implication of that should shake every space company on Earth. Blue Origin, SpaceX, Virgin Galactic are quietly selling tickets to this experience. 10 minutes for $250,000. Half an hour, more. Shatner was the demonstration. He came back and said on camera that it had felt like a funeral. Quote from his memoir, "It was among the strongest feelings of grief I have ever encountered. I discovered that the beauty is not out there. It is down here with all of us. Leaving that behind made my connection to our tiny planet even more profound." Listen to what he is really saying. He went up expecting wonder. He got bereavement, not because space was disappointing, because Earth from out there looked too precious to bear. That is the overview effect. That is what NASA has been measuring for 50 years. That is what the man on the rock in the West Texas desert was crying about. Go back to the desert. October 13, 2021. 90-year-old William Shatner sitting on a rock at the edge of a launch pad, champagne behind him, wind in his hair, hand pressed to his face. He did not know it yet. But a name had been invented for what he was feeling 34 years before he flew. NASA had been listening for 50 years. A space philosopher on a plane in 1985. An MIT doctorate floating in front of a rotating window in 1971. A Catholic physicist swapping film rolls on Christmas Eve 1968. A young psychologist coding transcripts in a Philadelphia office in 2015. A VR engineer in Tilburg wiring electrodes onto a student's scalp in 2024. All of them were quietly building him a vocabulary. He did not need it on the rock. He just needed to cry first. The words would come later. Here is the part the astronauts kept saying that we did not believe them about. The overview effect is not the postcard. It is not the cosmic high. It is closer to the feeling of realizing all at once how loved and how endangered something you had been taking for granted is. Borman called it fragile. Mitchell called it samadhi. White called it a cognitive shift. Sagan called it home. Shatner called it grief. Yaden called it self-transcendence. They are all describing the same moment, a 200,000-year-old species, for the first time, briefly catching sight of itself. Now look at your own life for a second. You do not need a rocket. Have you ever stood at the edge of an ocean and felt very small? Have you ever held a newborn and felt very temporary? Have you ever looked up at the Milky Way and felt the bottom drop out of your chest? That is the same family. Different doorway, same room. The astronauts just found the loudest door. And maybe this is why we keep going up. Not for the view, not for the flag, for the rewiring. Every century or two, our species needs a way to be reminded what it is standing on. We climbed mountains, we sailed oceans, we climbed to the moon. The destinations change. What we are looking for does not. Most of us will never see Earth from space, but every one of us is on it right now. That is the strange privilege the astronauts came home to tell us about. Not that they had been somewhere amazing. That we are. Pale blue dot. 6 billion kilometers from itself, holding everything, including you. Right now, watching this, 200,000 years to see it once. 60 years to start to understand it. We are still translating. And as we keep building up there, planning Mars, filling low Earth orbit with satellites, we are quietly making the sky busier than it has ever been. Right now, more than 10,000 active satellites circle overhead, each one going 17,000 miles an hour, most within a few hundred kilometers of each other. Picture this. One satellite hits a dead booster. It shatters into thousands of pieces, each piece a bullet. Each bullet hitting another satellite. A chain reaction in low Earth orbit. A wall of shrapnel locking us inside our own planet. No GPS, no weather forecasts, no new space flight. The overview effect, suddenly impossible to repeat. A NASA scientist named Donald Kessler warned us about this in 1978. And in 2026, his nightmare has a name. Kessler Syndrome. The day humanity lost the sky. Title suggestions. 5 options. The overview effect. Why astronauts cry in space 2. Why Shatner cried after 10 minutes in space. 3. The photograph that made astronauts weep for 50 years. 4. NASA spent 50 years measuring this astronaut feeling. 5. The 200,000-year-old feeling hidden in space.